Astronomers have observed a reclusive neutron star in a famous supernova. The question has often been asked what remains of the star that exploded just outside of our galaxy in 1987. So far, debris has obscured the view of humans, but two of NASA's X-ray telescopes have revealed new information. Since astronomers captured the bright explosion of a star on February 24, 1987, researchers have been looking for the squashed stellar core that should have been left behind. A group of astronomers using data from NASA space missions and ground-based telescopes may have finally found this. As the first supernova visible to the naked eye in approximately 400 years, Supernova 1987A or SN 1987A sparked great excitement and interest among scientists and soon became one of the most researched objects in the sky. The supernova is located in the Large Magellanic Cloud, a small companion galaxy to our own Milky Way galaxy, which is approximately 170,000 light years away from Earth. While astronomers watched debris explode outward from the site of the detonation, they also looked for what should have remained of the star's core, a neutron star. Data from NASA's Chandra X-ray Observatory and previously unpublished research from NASA's Nuclear Spectroscopic Telescope Array or NuSTAR, in combination with data from the ground-based Atacama Large Millimeter Array or ALMA, reported last year, now present an intriguing collection of evidence for the presence of the neutron star at the center of Supernova 1987A. For over 3 decades, astronomers have been sifting through the stellar debris of Supernova 1987A to discover the neutron star that they expected to be there. There have been a lot of clues that have turned out to be null and void, but we think our latest results could be different. When a star explodes, it collapses onto itself before the outer layers are blasted into space. The compression of the core turns it into an extraordinarily dense object, with the mass of the sun squeezed into an object only about 10 miles across. These objects have been called neutron stars because they are made nearly exclusively of densely packed neutrons. They are laboratories of extreme physics that cannot be duplicated on Earth. Rapidly rotating and highly magnetized neutron stars called pulsars produce a lighthouse-like beam of radiation that astronomers detect as pulses when its rotation sweeps the beam across the sky. There's a subset of pulsars that produce winds from their surfaces, sometimes at nearly the speed of light, that create intricate structures of charged particles and magnetic fields known as pulsar and nebulae. With Chandra and NuSTAR, the team found relatively low energy X-rays from Supernova 1987A's debris crashing into surrounding material. The research team also found evidence of high-energy particles using NuSTAR's ability to detect more energetic X-rays. There are 2 likely explanations for this energetic X-ray emission. First, there may be a pulsar wind nebula, or particles being accelerated to high energies by the blast wave of the explosion. The latter effect does not require the presence of a pulsar and occurs over much larger distances from the center of the explosion. The latest X-ray study supports the case for the pulsar wind nebula, meaning the neutron star must be there, by arguing on a couple of fronts against the scenario of blast wave acceleration. First of all, the brightness of the energy X-rays remained about the same between 2012 and 2014, while the radio emission detected with the Australia Telescope Compact Array increased. This goes against the expectations of the researchers and astronomers in relation to the blast wave scenario. Next, they chose to estimate that it would take almost 400 years to accelerate the electrons up to the highest energies seen in the NuSTAR data, which is over 10 times older than the age of the remnant. Astronomers have wondered if not enough time has passed for a pulsar to form, or even if Supernova 1987A created a black hole. This has been an ongoing mystery for a few decades, and we are very excited to bring this new information to the table with this result. The Chandra and NuSTAR data also support a 2020 result from ALMA that provided possible evidence for the structure of a pulsar wind nebula in the millimeter wavelength band, while the blob has other potential explanations. Its identification is a pulsar wind nebula could be substantiated with the new X-ray data. This is more evidence supporting the idea that there is a neutron star left behind. If this is indeed a pulsar at the center of Supernova 1987A, it would be the youngest one ever found. Being able to watch a pulsar essentially since its birth would be unprecedented. It might be a once-in-a-lifetime opportunity to study the development of a baby pulsar. The center of Supernova 1987A is surrounded by gas and dust. They have mentioned that through the use of state-of-the-art simulations, they have acquired an understanding about its material and how it would absorb X-rays at different energies, enabling more accurate interpretation of the X-ray spectrum, that is, the amount of X-rays at the different energies. This would also enable the research team to estimate what the spectrum of the central regions of Supernova 1987A is without the obscuring material. More data is required to strengthen the case for the pulsar wind nebula. An increase in radio waves accompanied by an increase in relative high X-ray in future observations would argue against this idea. On the other hand, however, if astronomers observe a decrease in high energy X-rays, then the presence of a pulsar wind nebulae would be corroborated. The stellar debris surrounding the pulsar plays an important role in heavily absorbing its lower energy X-ray emission, making it undetectable at the present time. The computer model predicts that this material will disperse over the next few years, which will reduce its absorbing power. Thus, the pulsar emission is expected to emerge in about 10 years, revealing the existence of the neutron star. Like, comment, share, and subscribe. Of course, this is fascinating space information. And of course, a neutron star so close to us is an opportunity for astronomers and researchers alike to gather further information about the development and formation of these neutron stars. Of course, have a wonderful day and continue to learn and acquire knowledge and share with your fellow men. Have a wonderful day. Take care and goodbye.